this session is actually talking a lot more about the future of voice. Where is voice heading? Why is it important for everyone around here to pay attention to voice, and how big of an interface voice is becoming in the way you deal with your customers, and how do you provide the best kind of customer experience on this particular channel. So this is a lot more forward-facing talk. It isn't the detailed product talk. That's going to happen soon enough, but this tells you why this particular interface is important. And so with that, that doesn't work. So with that, there's a set of things that we're going to talk about, right? So I'm going to start off with what is the state of voice right now, what is happening in the world of voice, and I'm going to go into detail as to the different voice use cases that are prevalent at this point in time. How are people using it? Because one of the advantages that Pindrop gets is because we have become the pioneers in a lot of voice technology, we get to see a wide variety of use cases that people are using voice for. And so what are the different use cases approaching voice? Voice has existed for a really, really long time. Why is it now that there is such a renaissance in voice? What is making it such a favorite interface for a lot of devices to adopt? What a lot of you folks are new world as we see voice proliferating, what changes in the security? That's what we're going to talk about, we're going to open up for questions. Voice, right? So there's a lot of numbers that are floating out there, right? So each of the device manufacturers tries to outdo each other and talks about how massive their voice user base is, right? So Apple came in and said, oh, voice is present on 500 million Siri iPhones. Google, not to be outdone, came back and said, yeah, we're on 500 million devices as well. So, by all counts, voice is available as an interface on over 1 billion devices. But that doesn't really matter. What really matters is what is the engagement on voice. And voice is fundamentally proliferating in 3 different areas. The first is smart speakers, where there are about 47 million monthly active users. And this is the most important factor, right? How often are people actually using that particular interface on a monthly basis? Because if you're just using it once and done, it's not really a very, very engaging interface. And so on the smart speaker space, so your Alexas, your Google Homes, your Sonos, your Samsung Bixbys, that's about 47 million users, and they actually repeat very, very aggressively. So 47 million users, and 80% of them come back and do something on a daily or monthly basis. So it's very high engageability there. The other, which is actually pretty massive, is there's about 77 million connected cars. So people using voice on connected cars. So Ford, Mercedes-Benz, BMW, all of these different manufacturers have lineups of their cars where they're increasingly becoming voice aware. And the really interesting thing here is Tesla changed the way interfaces were looked at in cars. If you look at a Tesla car, you have a massive touchscreen on that car, and so a lot of car manufacturers started going the touchscreen route until Mazda came out with what's known as the swipe and swerve report. So what happened is they started testing how people were using their touchscreens, and then they found a really interesting thing, that every time someone was swiping on the touchscreen, they were mildly swerving off the lane. And so that report put a stop to a lot of the big touchscreen interfaces, and so a lot of the car manufacturers have massively shifted to a completely hands-free interface, and voice is becoming the most prevalent interface in those areas. And so right now there are about 77 million connected cars which use voice as the primary interface. And they also have a very interesting, they have about a 70% repeat rate on a monthly basis. And then finally, the smartphones, right? The actual device that you use, your mobile phones. A lot of people use that voice interface to search for apps, to search for products, to buy things, and you have a virtual assistant in each of these devices, right? Samsung has Bixby, which isn't doing so well. Apple has Siri, Microsoft has Cortana, and Google has Google Home, right? And so has OK Google, and there's about 90 million smartphone voice activated users on a monthly basis, and they have a repeat engageability of about 60%. So these are all massive places where voice is proliferating, and the only reason I bring this up is for you to realize that voice is actually becoming pervasive in everything that consumers are starting to do, right? If you're in your home and you have some kind of smart speaker, you're using voice. If you're in your car traveling around, you're using voice. If you're in the office using your smartphone, you're using voice. And this is becoming more and more pervasive, and this is where people are finding that a lot of their customers are engaging with them more and more on voice. And I'll talk a little bit about the stats around that, and it's really surprising how quickly those numbers are growing. And if you actually look, most voice interface folks look at the way voice is proliferating. So the first voice device that really started doing things was the iPhone and Siri in 2011, but it really didn't take off until 2014 with the introduction of the Amazon Echo. And that phase, so phase one, was largely spent on trying to make these devices understand what you're saying, or what is known as automatic speaker recognition. And I'll talk about these technologies in just a bit, so don't worry too much about the acronyms. But a lot of the phase one was spent in trying to identify what you're saying, and then trying to identify what you're saying in a variety of different languages, right? So, Amazon allows for 60 different languages, Google allows for 90 different languages. So they're proliferating in making these devices available and with high enough accuracy in a variety of different languages. And it introduced everyone to the concept of voice as a brand new interface. Even though voice has existed as an interface for a long time, voice as an interface is something humans communicate very, very comfortably with. But it is, fundamentally, there's a lot of changes that have happened in voice, but that was phase one. And now we're starting phase two of the entire voice explosion, right? Where there's a lot more focus spent on what is known as natural language processing, which is trying to understand the context of what you're saying, trying to understand what you mean even when your language is extremely ambiguous like English. And I'll talk a little bit about that in just a bit. It's also proliferating in a lot of devices where traditionally it was smart speakers, connected cars, and your smartphones. You're seeing a massive explosion of voice in TV remotes, in headphones, in washing machines, in refrigerators, and so on and so forth. So you are becoming more and more surrounded by these voice devices, and we're working with several folks in these spaces, right? We see the kinds of interactions that people do on these TV remotes, and it's wonderfully fascinating, and we'll talk a little bit about that as well. So, more and more devices, and because you're able to not only understand just the words of what someone is saying, but the context and what that transaction really means, these voice devices are becoming more and more capable. It's not just playing your favorite radio station, but starting to do shopping and purchase and commerce and ads and things like that. And so we're entering phase two of the voice revolution. And this phase, you're starting to see a lot of use cases expand in this particular phase. So just to go into some of the use cases, the first one that I want to talk about is more and more people are doing voice purchasing, right? And so if you actually look, it's really, really interesting. 46% of people are, purchasing things like clothing. I know someone was there from Macy's. Teresa was there from Macy's. It's really, really interesting to see the trend. Until last year, no one was doing purchasing on these voice-activated devices, and no one was doing banking as well. But these numbers have started to increase. And if you actually look at the actual breakdown, now what people are finding is 30% of users are finding that they're actually starting to search for products using a voice-based interface. Another 30% are actually moving those products that they search, recommended by that voice interface, into things like a shopping cart and things like that. Another 18% are actually going forward and actually buying things on that. There's still small percentages at this point in time, but the fact is that you're starting to see that voice purchasing muscle being exercised more and more on these voice activated devices. And not only is it, purchasing and things like that, but banking also is starting to do. And banking, there's a few use cases, things like payments and things like that are starting to become more and more pervasive on these interfaces. The second big thing that's happening is voice search queries, right? It's really interesting because China is actually leading the way here. 10% of all Baidu, which is the largest search engine in China, are actually voice-activated searches. In the US here, Google has found that on the Android phone, in the case of Baidu, it's all searches, so it's a much larger universe. In the case of Google, on the Android platform, 20% of all searches are actually a voice search. So 1 in 5 queries are actually becoming a voice search. And Google and Baidu predict that by the year 2022, this number is going to go to about 50%. So 50% of all searches are actually going to become voice-based searches. So every other search is going to be a voice search. And so it's important for you as part of your brands to start realizing that consumers are going to become increasingly interested in interacting with you in a voice-first world. The next big thing is how much people are spending on voice ads, right? The projection is about by 2022, there's going to be a $19 billion spend in ads on voice. And really, really interesting is that 25% of consumers have actually heard an ad on smart speakers, and the population that was sampled was a pretty large population of about 4% of US adults, right? So it's a pretty large statistical sample, and so a very large number of them have started already seeing ads on these voice devices, and about 38% of them find these voice ads less intrusive than an ad that they would see on the digital or the online platform. And so it's really interesting that you're seeing, one, people are just searching more using voice, people are purchasing more using voice, and you can target people more using voice. So this is actually the 3 holy grail at which point an interface starts becoming real, right? Because the more you actually interact with an interface in terms of search, in terms of spend, in terms of discovery, you're going to then start using that interface as a very, very easy way for you to determine things. And it's really interesting because a voice-based search is actually restricted. That is, you can't show an entire page of results. A lot of the Google I'm feeling lucky kind of concept, where the first recommendation that a particular voice activated device is providing is often the recommendation that most users are going with. So in a survey, about 67% of users said that they would be perfectly fine buying the brand that was first suggested when they made a particular search on a voice-activated devices. So for example, if someone's looking for a piece of clothing and the first response comes from Macy's, they're willing to go buy that 67% of the times. If they're trying to do stock trades and the first response comes from E-Trade, then they're willing to go purchase, make that stock trade on the E-Trade platform as opposed to any other platform. And the same thing with banking. If they're planning to do a mortgage or payments or any of those things, the first thing that's able to answer them and give them a good answer, they're willing to go with that 67% of time. So it's something important for you to look at, because that's the way people are going to start looking at these things. And in the newer generation, right now the average age for someone to get a mobile phone, the earliest average age is about 12. So people are getting phones much earlier, and so in a lot of these cases, they're coming into these devices. So this is the Gen Zs of the world, and whatever the next generation is called, right? Gen Zs of the world, they're getting phones when they're 12, and they are not encumbered by the older habits of saying, hey, I need to go through menus, I need to search sequentially and then find my answer. They're more prone to whatever is the interface of choice that gives them instant gratification, and voice is quickly becoming that particular interface. So, lots of things happening in voice. So why is it that voice has become so popular right now? What is it that's making that change? And fundamentally, it's three things that affected that change. The first is what's known as automatic speaker recognition, or ASR. I talked about this a little while ago. The second is natural language processing, and the third is text-to-speech. And I'll actually show you the performance of such a system from 2000, right? There was the Microsoft SAM device back in 2000, which also did, voice recognition and text-to-speech. And the most recent example from Google Duplex in 2018, and you will see the fundamental massive difference between these two, devices. And so let me just quickly run through what each of these technologies mean and what it means to you as a brand, right? So the first is automatic speaker recognition. Automatic speaker recognition is fundamentally the way this particular device understands words that you're saying. And for the longest time, it was a very, very hard problem. Even back in 2012, the word error rate was 30%. What that meant is if you actually had 20 words that you were saying to a particular device, it would only understand 12 out of those 20 words. At that point in time, it's understood only 2 sentences out of the 3 sentences that you've said. And so it really has no clue about what you're trying to say. And so that was the state of the art until 2012. And then there is a field that completely changed each of these areas. It's deep learning. A lot of you folks know deep learning from self-driving cars and facial recognition. But deep learning also revolutionized a lot of voice recognition. And the word error rate drastically started dropping from 2012. Right now, the word error rate is sub 5%. What that means is out of 20 words, the system will actually understand 19 out of the 20 words, and actually it really doesn't even matter what the 20th word is, because there's just so much context that you have a great shot at guessing what that 20th word is. So a lot of these systems are now at word error rates of less than 5%, and interestingly enough, human parity, that is when two humans meet for the very first time, their word error rate is also 5%. So the fact is that we've actually achieved human parity, and human parity got achieved in 2018. Now the latest numbers that most people have in their word error rates are around the 3 to 4%. So we're quickly surpassing, and every percent after 5% tends to be much harder than whatever you've gotten to that point in time. But that's the thing, right? These systems are becoming so good at understanding the words that you're saying, even with accents like mine, right? My Google, my Amazon, I have, several voice-activated devices in my house, and it's sometimes it's funny. They all turn up at weird times in the night, and it's an interesting experience. But the fact is that these devices are able to understand my accent really, really comfortably, because these devices have become so good at solving that automatic speaker recognition or word error rate problem, right? So that's the first part. The second part is what's known as natural language processing, which is when you actually say, hey, I want to book a table for 4 in English, do you mean for 4 people, or do you mean at 4 p.m., right? And so there's a lot of ambiguity in each language. And even when you're trying to do a transaction, let's say I'm trying to do a payment transaction, we did a little analysis. We took a bank's call data, and we looked at the number of ways people could arrive at the fact that they wanted to do payments. And there were 19 distinct ways in which they could do that, right? So you're trying to just do a payment, and there are 19 different ways that you actually arrive at that answer, right? And so it's an inherently complex task to understand what humans are saying, and humans tend to do all kinds of crazy things, right? Like you're talking about something and suddenly something catches your fancy and you go down another tangent and then you bring back. And so maintaining context, maintaining several sentences of context and trying to understand the natural language that is English or any other language is a really, really hard problem. The really interesting thing is, and this is where I'm a PhD by training, and so I always like to say where is truly the world and where it isn't. There's a lot of people that believe that you can actually now start talking to these devices, and it's going to become your therapist, and you're going to have wonderful conversations where you're going to understand the meaning of life and things like that. That's not happening. That's not happening for 20 years, right? So that entire notion of generic NLP, that is, you could have, I mean, I had wonderful conversations sitting in multiple tables on a variety of topics, right? What was our Christmas vacation? What are you doing for fraud? And we could switch conversations so easily. That kind of a conversation happening with these voice devices is a really long time away, right? And most experts in this area, the fathers of deep learning, the people who've created deep learning as a branch, also believe it's about 20 years away. So what does that mean, right? Like, how do you do it? How do you use this particular system? What is actually a solved problem is what's known as domain-specific natural language processing, which is if I want to do a very specific transaction like payments or stocks or buying clothes, something very, very narrow, if you want to do something very narrow, that's where these systems come alive, because if you train them with enough hours, and the amount of time that you need is roughly in the order of 30 hours or more. So if you have 30 hours of people trying to order clothes, you can actually get a system, and you have to teach it certain concepts like the notion of an order. The notion, in the case of the example that I'm going to play, it was a simple appointment setting skill. And the appointment setting, you had to teach it what is an appointment, what is a time of day, what is the appointment that you're trying to set for, right? Like the fact that you want some kind of hair treatment, right? And so these are the concepts that you have to teach it. So the machine learner can't generically learn these concepts, and this is where it becomes really interesting for you as brands, right? You have to work with these folks, just like when you created the first websites or when you created the first mobile apps, you had to decide what was important for you. You have to teach the same kind of domain-specific things to the machine learning system or the voice-activated system, along with providing it tons of data to be able to learn what this actually means. And so that's the entire NLP piece of it. And a lot of people are doing really, really well when they're restricting it to a few skills, right? These are the few things that we'd like to cut off all our transactions, where we'd like a completely automated system to have a wonderful conversation. A lot of people tried doing this with chatbots, but chatbots don't have the ability for you to realize when the conversation is going wrong, because it can't pick up things like disfluencies, the fact that a person is getting increasingly frustrated with that conversation. So, chat by definition, because you just have text, has a lot of restriction in the fidelity of that communication. But when you get communication from a voice or a video standpoint, you're able to capture a lot more and fundamentally make that conversation a lot richer than normal. And so a lot of people who invested in chat earlier are starting to get the same benefits with voice skills. And what they're doing is they're training those voice skills with the gamut of voice information that's available there. And then finally, you have TTS, which is text to speech, which is how do you give your brand a personality? And a lot of people spend time in if you are speaking to a voice activated device, if it speaks to you in an extremely robotic fashion, or it speaks to you in a fashion that doesn't signify your brand, you're going to start losing your customers there, right? And so therefore, a lot of people are spending time in the text-to-speech space trying to figure out, hey, is my brand a very serious brand? Is it a fun-loving brand? And so that's where they're spending a lot of time. And so we're finding a lot of customers spending time in the text-to-speech side trying to determine what is the right voice for their interaction. And so again, it's extremely interesting because if you actually look, I'm going to play an example of this. You're going to see two different systems and the way they actually interface. The first one is the Microsoft interface, a voice interface from 2000, and you're going to see how bad that sounds. And the next one is the Google Duplex, where the machine is automatically setting up an appointment with no human intervention. Before this Google Duplex system was trained over 23 hours of appointment setting and taught various concepts in appointment. So let me just quickly run through that. Hopefully, we have volume. Can people...
The quick brown fox jumps over the lazy dog 1,234,567,890 times. Swoof.
So that's a horrible, sounding text to speech. And this is a completely, so there are two people talking in this next interaction. One of them is human, the other is a complete machine, which completely, has no human intervention.
So how can I help you?
Hi, I'm calling to book a women's haircut for a client. I'm looking for something on May 3rd.
Sure, give me 1 second. Sure, what time are you looking for around?
At 12 p.m.
We do not have a 12 p.m. available. The closest we have to that is a 1:15.
Do you have anything between 10 a.m. and 12 p.m.?
Depending on what service she would like. What service is she looking for?
Just a women's haircut for now.
Okay, we have a 10 o'clock.
10 a.m. is fine.
Okay, what's her first name?
The first name is Lisa.
Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd.
Okay, great. Thanks.
Great. Have a great day. Bye.
So the appointment setter, the one that said, this is an appointment for Lisa, is actually a complete machine, right? And it's so good that they've introduced things like disfluencies. Like I said, when the person repeated, oh, she wants an appointment at 1:15 for a haircut, she said, right? Like that's the little sassy in that assistant actually saying, yep, I just said that 2 minutes back, so that's exactly what I meant, right? And so this is the beauty of voice where it stands right now, right? It is becoming very real, and that machine completely did, and now, that system is, you can book your own appointments using that system by a simple OK Google command right now. So it's actually pretty cool, and it does all kinds of things, right? In my case, I was looking for a anniversary dinner, and so what it did is it went through a bunch of different apps to figure out, Vijay's anniversary dinner is this because his calendaring app says his anniversary is on Feb 6th. Oh, then the next thing that I'm going to look at is his Maps app and figure out that his home location is 1058 Oak Point. Then I'm going to find out restaurants around that area using Yelp and find out restaurants that were tagged with romantic, right? So it collected 3 different apps, figured out all of that, and then came back to me and said, hey, would you like a dinner appointment at 8 p.m. at Rumi's Kitchen, right, which is a great Persian restaurant around my area. But that's the beauty, right? That's the power of these systems, that they can take what would take me hours to do, to go through these different things, figure out, look at ratings, all of that stuff. It came back with a suggestion, and given, of how much time I spend with Pindrop, the fact that it told me where I needed to go for my anniversary in a matter of 2 minutes was a lifesaver. So jumping to, this is a wonderful world, right? Like voices, is an extremely fast form of communication. It's really important because, especially if you're someone like me, I speak so quickly that I can get so much more communicated in a single minute of voice than if I had to spend that time typing all of that out, right? And so the fact is that 1, naturally, it's a much, much faster interface. 2, it is an interface that requires very little, right? So this is the microphone on my phone. It's a microphone array. It's really, really small, and that's all it requires for that interface to be enabled. That's why at CES you have smart rings, smart watches. Really, really small form factors can fit a voice interface on it, right? And so, you're starting to see that that explosion because of those factors. Having said that, what does voice security look in this new world, right? Because it is a scary world, and we will tell you, right? Like, we've been playing in the voice space for a really long time, and the rest of today's conversation is going to be a lot more in the area that we're well known for in the call center world, where voice currently is massive. So a lot of people think voice is something new, but call centers have had voice for the longest time. In fact, there are about 3.6 million call center agents here in the US. So 1 in every 89 Americans is actually a call center agent. And that's 10 times the number of Uber, Lyft, and taxi drivers, right? So, it's a massive amount of voice that already comes into the US. About 47 billion voice interactions come to organizations. And if you actually look at the amount of fraud, so this is the amount of fraud that Pindrop itself has caught, right? So in 2018, we caught about 346 million in fraud dollars that people were trying to attack, right? And so that's giving you a sense, and till date, we've caught about 750 million. So it's telling you that a voice is an extremely susceptible channel. And in fact, the amount of voice fraud we've seen constantly increase, right? 1 in every 700 calls right now, on average, turns out to be a fraudulent call. And when we started, that number was 1 in 5,000. So it's gone from 1 in 5,000 calls being fraudulent to about 1 in every 700 calls being actually fraudulent. So it's exploded, and right now the estimates are that about 90 voice-based attacks every single minute in the world. So it is a channel where a lot of people are targeting it, and the reason that they're targeting this voice channel is because if you look at the physical security and the online security worlds, they've had years of attacks, and lots of people have created a bunch of defenses. So if you look at your online systems, you have 7 layers of defense, starting with something as simple as a firewall to something that detects APTs and state-sponsored terrorism. You have systems that look at the gamut of threats and protects you against that. On the voice channel, there's none of it, right? All you have is questions, right? What's your mother's maiden name? What's your date of birth? And questions like that. And I keep repeating this call because it's one of my favorite calls. There's a fraudster who called in, and the call center agent says, "What's your mother's maiden name?" And his answer is, "My dad married thrice, so can I take 3 guesses?" Right? That doesn't even make sense, right? So what if your dad married thrice? You still have 1 mother. But the call center agent gets confused and says, "Sure," right? And he takes the top 3 mothers' maiden names in the US, and his last one is Smith. It turns out to be right, and he wires $90,000 to a bank in England, right? And so that notion that you are using these really, really stupid questions to protect your customers' accounts is a very, very antiquated notion, and that's where a lot of fraud is happening. It's not only happening on the voice world. You're starting to see, how many of you are aware of deep fakes? Okay, few people. So deep fakes is, again, using machine learning to start creating machines to start impersonating humans, right? Both in terms of voice and video. So you have a massive proliferation. So that was Mark Zuckerberg, a deepfake video of Mark Zuckerberg saying that he was part of the Spectre organization and that he was going to take over the world using, his social media network, right? And these kinds of systems have become really, really, there's deepfakes of Nicolas Cage in every single movie, and it looks very, very real. And the same thing is happening in the audio world as well. So you're starting to see massive proliferation of deepfake audios. More importantly, we are aware of several such things. In August 30th of 2019, this was publicized, but there's a lot of details around it, where there was actually a deepfake voice synthesis system where a UK CEO called up the German subsidiary, and it wasn't the actual UK CEO. They'd used voice synthesis to actually generate the CEO's voice, and then convince the German subsidiary to wire money out. In that particular case, the public case, it was about $243,000. The largest that we've been brought to look at is about $11 million. So a CEO of an organization, the CFO being called, and $11 million transfer, and these transfers are becoming, what's happening is that the CFO is getting a call, and the CEO is saying, "Hey, I'm just ready to board a flight. I need this particular amount wired because I'm looking at this very, very interesting merger. I want this money wired in," and a quick wire happening as a result of that. And it might not be the CFO; it's someone on the finance department. And we're not only seeing that in terms of internal facing threats, but we're also seeing it in terms of external facing threats, right? So public personalities, deepfake videos and audios of them are surfacing on YouTube and a variety of social media channels where they're saying things that they never said, right? And so how do you protect against this notion, right, of deepfakes? And ultimately, we've been got in for a lot of what's known as the fake president fraud, where someone is purporting to be the senior officer of a company, calling in the calling the CFO, COO, and what they're doing is they're using a variety of mechanisms, publicly available data, company websites, social media. But in one case, we've actually seen them hack the private intranet, and in this particular case, this CEO didn't have very many YouTube videos of him speaking. So, in fact, he had no YouTube videos of him speaking, and so we saw logs of the person's audio being extracted out and from internal meetings, and that being used to create a voice synthesis. So, voice is great, but there's a lot that can happen in voice, and I'll talk about what you can do to protect against that. So, there's three big things that need to happen in order to make sure you identify the right speaker. One is you provide a system that's able to handle all the vagaries of humans and all the vagaries of devices that they come with, and I'll talk a little bit about that. The second thing that you need to do is you need to create a system that's dynamic, that is robust to people and how they change over time, and we'll talk about that as well. And then the third part is how do you make it secure, right? Given what I talked about with the proliferation of deepfakes and with the fact that there are a lot of voice attacks, how do you create a secure system? And so I'll touch upon each of that in the next set of 5 minutes and then open up for questions. So first is, how do you handle channel invariance? And the biggest thing with channel invariance is being able to handle noise. One of the biggest banes of voice recognition is being able to handle crazy amounts of noise. And for the longest time, people didn't know how to solve it. We've actually solved it using machine learning again, and we've solved it in a completely automated fashion. So what I'm going to play to you is a set of calls that are noisy, and an automatic machine learning system is scrubbing away all the noise from the system so that you can isolate the voice. How does this help? This helps because you're able to then focus in on the voice of the individual and then make a very, very quick determination. Is this the right individual or is this the wrong individual? And the really interesting thing is regular people call from a variety of environments. They could be calling while they're driving their car and there's a lot of noise in the background. If you can't recognize them when they're doing that, there is no point having a voice authentication system. It'll actually fail so often that you don't have enough accuracy that you'll stop using that system. On the other side, fraudsters tend to use noise very, very effectively. There's this particular fraudster who traditionally what she does is she uses a baby crying to create sympathy for herself in order to be able to make sure that when she's talking to an agent, she's constantly referring to the baby and the person is like, oh, okay, you know what, she's got her hands full, so let me make it easy for her, right? And so there's a lot of these things. There's also another fraudster. So if you come to Pindrop, every conference room is named after fraudsters. There's another fraudster called Chicken Man who uses roosters in the background to, again, distract people, right? And so how do you eliminate all of that noise to identify the source and figure it out? So I'm going to play a couple of things so that you see how we do this at scale.
There it clothes itself in word masks, in metaphor rags.
So you heard the siren in the background. This is at a very low level of noise. And in the next one, that siren is completely eliminated.
There it clothes itself in word masks, in metaphor rags.
So that siren completely eliminated at scale, without any human intervention, right? The next one is a frog croaking, and it's at a much higher, sound level.
Upon the large square in front of the hotel, the shadows of the tents, intersected by the golden moonbeams, formed, as it were, a huge mosaic of jet and yellow flagstones.
So you have that frog in the background. The next one is that frog completely eliminated.
Upon the large square in front of the hotel, the shadows of the tents, intersected by the golden moonbeams, formed, as it were, a huge mosaic of jet and yellow flagstones.
Okay, this is a frog which is pretty repetitive in the way it croaks. But if you have classical music which constantly changes.
Making their way across the river, most of the refugees found shelter among the more hospitable people of Clay County, and afterward established themselves in Caldwell County, therein founding the city of Far West.
right? And then finally,
Making their way across the river, most of the refugees found shelter among the more hospitable people of Clay County, and afterward established themselves in Caldwell County, therein founding the city of Far West.
so the noise completely eliminated. So how does this help, right? A lot of your callers call from a variety of environments, and therefore we're able to handle it. Just to show you one example, we're working with a car manufacturer, and these are our performance results. So even with extremely high, noise, so at 0 dB, it means the signal is equal to the noise, so it's as loud, and at minus 5 dB, the signal is actually lesser than the noise, so the noise is louder than the signal. Even then, we're able to identify a speaker with as little as 1.5 seconds with over 90% detection rate. So just to give you an example of what that sounds when someone's driving a car and they have their windows down.
Please play FM 93.5.
Yeah, so that's please play FM 93.5 with the windows down, and that utterance is about 1.5 seconds. So how do you identify someone with that extreme environment with extremely high accuracy? And so having a system that automatically detects that noise and eliminates it allows for us for doing that, right? The second is, how do you handle, human variances? So when they have a cough or a cold, this is actually a very famous study that we did with President Obama, and you can actually see from 2009 to 2016, you can see with his face itself, he aged pretty rapidly. In fact, if you look at 2015, he looks more aged than 2016 because, he was, at 2016, he knew he was done with the presidency, so he actually started getting younger, right? And so in 2015, and the same thing you can see with his voice, right? His voice aged over time, and this is a exponential scale, so every single unit that you see is an exponential degradation in his voice, and most voice recognition systems would stop recognizing him within his first 8 months of being president, right? And so how do you handle even extreme forms of aging like that? So, there are things that we've done, and if people are interested, right, we can talk about it, but you have to understand the concept of aging is a deeply human one. So how do you build a neural network that understands that concept? And a lot of voice biometric vendors, what they tend to do is just keep re-enrolling the customer. There's two problems with that. One, customers don't call very often. So if they call once every 8 months, that re-enrollment means you're in perpetual enrollment hell, right? Every time the customer is calling, you're enrolling them all over again. The second is, if you actually use that model for a customer who's constantly calling, you're going to enroll so often that you're going to make the model so bulky that it's going to get super slow in identifying that person. So how do you do something far, far cleverer than that? And then the final example that I'd like to use is, how do you detect things like voice synthesis? So this is actually a real life test where a Wired reporter ran John Legend. So John Legend, Google introduced this concept where you could actually speak to a Google Home device and you could say, Google, respond back to me like Legend, right? And it would respond back to you with John Legend's voice. And so what this Wired reporter did is he took a bunch of real sentences that John Legend said and a bunch of fake ones that were synthesized by Google's WaveNet system, ran it through our system, and we detected every single fake version of John Legend. We detected every single version, and so he wrote a glowing Wired article on our system. But that's fundamentally, what do you do? How do you use millions of years of human evolution to determine when a voice is synthesized and when it is real? And just to give you an example, I'm actually going to do a live quick demo. So that's, that's our voice synthesis system. And so you can have multiple voices. And so, and for people who've seen, so. I'm going to synthesize this. So this is happening in real time, just to show you how easy it is, right? So we have our own voice synthesis because we're constantly looking at what's the state of the art and how do you detect against that. And so this is going to go to YouTube, pull out videos of Trump, separate out Trump from all the other speakers, and then start getting a machine to understand how does Trump sound, right? How does he say certain words? What are his, eccentricities? And then it creates this.
This morning, American forces gave North Korea the bloody nose it deserves.
Right? So all on demand, right? And I can do the same thing for anyone's voice, right? And so even if I have about, and this is just 5 minutes of President Trump's voice, so if you have more things, but what's happening behind the scenes within Pindrop is it also has a voice recognition engine that's saying, okay, this is 107 times likely to be President Trump over anyone else. But just like humans, we always have a hopelessly optimistic side and a deeply paranoid side. You know, when you're a kid, my son is 18 months old, everything is optimism, right? Unless he runs into a wall. He knows, okay, now I can't run into a wall anymore, right? And so it's the same thing, right? You're always in love until you've had your first heartbreak, right? So that's the portion. So these two portions compete with each other. The hopelessly optimistic side, which is your prefrontal cortex, and the super paranoid side, which is your flight and fright response, which is your amygdala, they're constantly competing with each other. So the same way we've been inspired by that to build two different neural networks. One's constantly trying to say what's good in this world, and therefore this is 107 times likely to be Donald Trump. But then there is a hopelessly paranoid system or a super paranoid system that's saying this is 79 times likely to be a synthesized voice. And so when those two compete, the other one says, you know what, even though this feels like President Trump, it's most likely a synthesized or replayed version of it. And using that information, it actually creates defense mechanisms to protect organizations against attacks as complicated as a voice synthesis attack. So with that, let me just quickly, I need to get my mouse back here. I'm going to end with one final slide before I open up for questions. So, we're in the middle of a computing paradigm shift, right? In the 1990s, when the online became big, each of you started creating websites because you wanted to, make sure your customers are serviced not just by brick and mortar, but also by an online presence. And companies that failed to do that, so that's a quote from the CEO of Blockbuster, which said that neither Redbox or Netflix are even on the radar screen in terms of competition, and we know how that ended. In 2000, when the iPhone became big, again, there were people who missed that boat, right? This is a quote from Steve Ballmer, which says that there's no chance that the iPhone is going to get any significant market share, right? And we clearly know how that story ended as well. And now we're in the middle of the conversational economy, right? With all of these devices proliferating. So you need to decide whether you're going to adopt this and start providing your customers with the instant way in which they want to interact with your brand, or whether you want to be one of those other CEOs. So